Hello? Anybody on? Okay, we got new things here. What's up here?
When you're selling a solution to
Sorry about that. I'm trying to participants audio return.
So you're a startup company.
Okay.
1,000 users, maybe a million.
Where's video? Video.
You connect to us. You do a small.
Okay, so hello. Georgi twice. Why do we say Georgi twice?
So, and then from there we give you back details and pictures on the
whiteboard.
So you get to do that for free. So it's like white flag line with only a single user's email. You can have this useful information about how to better maximize their experience with it. You're only getting what they care about, nothing else. So maximize the experience.
We're still waiting for students.
The whole goal of that is we can get lots of user data. And then from there build out a really intelligent system. And then from there, how do you make money? Well, large. Give it away to startups, large enterprises.
to get the word about that.
I'm the presenter.
Yeah, with that reputation.
So now I can.
From what I see, the enterprises are willing to pay between 20 to 40,000 a month.
Hello.
For a good amount of money for.
So are you a student right now or not?
Okay.
So how do you pay your bills?
I have been an entrepreneur since some time in my college career, and for a little bit I was making a fair amount of money. Now I'm not making as much money. I also worked with a company and
I see.
Before
You were with a capitalist.
well, I think
Hello class.
I think
So did you connect to WebEx? Hello class. We are waiting for waiting. Were you able to install Ubuntu?
Oh, that's right. I could not download it. I tried yesterday and today again, and we just crap out halfway through.
the download.
Yeah.
So why was the link wasn't working?
It would start working. It's just been taking way too long.
Oh, okay, so you can start downloading now if you the network is good. It's 4 gigabytes. I've actually uploaded another one. Let's see, Georgi Chinkov. Now, is this Bulgarian or Russian? Georgi. Oh, you speak Russian. You are, no, Lithuanian. Russian.
From Russian.
So you're from
I was
Lithuania.
born there.
Isn't there like a small part of Russia inside Lithuania or something?
Next to it.
I thought that there is no corridor. It's kind of like isolated.
Yeah, it's really big.
Хорошо. Meetup.com. So we have a very high drop rate. People are not coming.
What about the other?
Did you register for the class today? Probably not.
Yes, I am.
Really? I think what I want to make clear is that people think that if they lose a class, they miss a class, then they can continue. But I should emphasize that somewhere that it's kind of like self-complete. Maybe some people get disappointed from the Hadoop experience.
I didn't have an opportunity to do.
Yeah, it was like last Friday.
Okay. That was 1B or something like that, or?
Yeah, because it's 2B. So, you can put the, you can use the Ethernet and try to. Or maybe I should find a better mirror, a class layout, less on assignments. Got my book. Promise. So let's see here. Have you been able to install the VM? We're gonna wait for another 5 minutes and show up, then we'll make it sort of private. So right now you're building this platform. And
Right now, it's just the function of I haven't yet applied all the machine learning that to the system. Right now, we have the ability to gather all this data, and now I need to either find quote unquote an expert, or I need to follow the math optimization that I know and the.
What is your major?
So I studied industrial and system engineering. With operations research, I took 200.
You know that this company is all about predicting industrial ISY, like we got a lot of people.
Yeah, and so I studied I took 240 credit hours in 6 years, and I did some startups as well. I don't know how the hell I did it when I looked at it. I didn't have a life. No, I had a life, not really. I don't know.
You should hire Diana. She's pretty good at. Very handy.
How do you
through meetups?
Meetups? Yeah.
That's doing well in terms of.
I'm just thinking of applying Apache Mohawk. Not a good.
Try GraphLab or depending on the scale. I mean, if you want, we can meet at some point and have give me a overview. I can how to start. Not really. Development.
It's not really progressing.
And Apache is probably the worst paradigm to fit for machine learning. Our Hadoop has more chances to be better than. But finally, I'm also in this area. That's the problem, and also if you're interested in funding, if you want me, I can refer you to this too. Please, it's up to you. So, I think about 17 people had registered today, and only 4 showed up. Okay. Can you hear me now?
Okay, working.
1, 2, 1, 2.
Oh, is that what it is?
Oh, I know what. we are about to start. So last time, so first of all, if you have any questions, the remote students, Georgi and Jacob, please write them on the wall because chat is not that easy to view. And please feel free to stop me and ask questions during the process. So we go to the Meetup website at lesson 2. So for those of you who are new and you don't know the process, you have to go, I'm posting it right now on the chat. You have to go to this link. Now, you don't really have to connect to WebEx now, because we're just a family today. It's not... Okay, so your first task is to run your first linear regression. If you remember from the past class, when we tried the linear regression on the airline dataset, we couldn't really even load it, or even if we were able to load it, it was taking too long to process it. So there is this package called Big LM, and you can start running the example as you see it over there, and I'm going to explain how Big LM works. So I see Navar also registered, has just joined in. Oh, that's you? Is this how you write your name?
Yeah.
I thought it was Noir. Oh, okay. All right. So you just joined. Were you able to join, Diana? Yeah. That's interesting. You have a Java problem? Are you running Win? You can sit next to Noir, so that's fine. So basically, are you running on the virtual machine right now? Okay, so open your virtual machine, and the datasets are already loaded on the VM. So you can start, loading and running the Big LM.
When you say the virtual machine, are you talking about loading Ubuntu and turning on R in Ubuntu?
Yeah, I mean, you turn on Virtualbox, and then you start your Ubuntu, and then you start R over there. So you're still downloading it?
Before I ran R on Windows, and I had it working, but I know no one likes running.
So feel free also to try the Revolution Analytics one. It's much faster and a little bit easier in some for some tasks. For example, the native linear regression on Revolution Analytics is very, very scalable. So Big LM still requires from you to load all the data sets in memory. But what it does, I'm sorry, actually, Big LM doesn't. Sorry, I take that back. No, it still requires to do everything in memory. Now, the trick is that you can incrementally update your regression. So technically, if you have a big data set, you can upload, a small chunk, run the regression, then upload another chunk, update the regression, and keep going. So technically, if you're able to split your file into smaller files, you can run your regression. For example, here you see that we ran the regression for 2007, and then we removed 2007, and then we load the 2006, and we update the model, and then you can put 2005. And if your computer doesn't have enough memory to support 2007, you can split it in smaller chunks and start running. So basically, BigLM requires only, if you have D factors in your model, it requires D square memory. So if you have 10 factors, it requires 100 elements of memory, depending on how much. I don't know exactly how much memory R stores per element. It's pretty high. So basically, if you had very strong restrictions with memory, you could load only one line at a time, like 1 point at a time, and update the regression. And it's based on, I don't know if we have anybody who is more mathematically savvy. You said you know math, you've done optimization. So basically, it's rank 1 updates on the matrix. That's what it is. So in rank 1 updates require D square operations. So is everybody, so have you started running it?
I'm running Windows right now with Ubuntu.
Okay.
Sorry, I'm running Windows for
Okay.
right now.
That's fine. You will have to switch to Ubuntu once we start our Hadoop. So what about Jacob or Georgi? Are you running it? Do you have any problems? This thing work? Oh. So we're not getting any response from the remote students. I don't know. So are you, I don't know, nothing. Are you done with assignment? Also notice that something we discussed in the previous class, day of the month and day of the week, they might be represented with numbers, but they're actually factors. So the number doesn't really mean anything. The number, we discussed in the previous class course that day of the month and day of the week is categorical variables, and it would be wrong to represent Monday with 1, Tuesday with 2, Wednesday with 3, because we give a very, very high bias in our model. Because if somebody was going and running the same problem with different categorization of the week, so it would assign Saturday as day number 1, he will get completely different results, and that's not acceptable. So instead, what we do is that we replace the days with this. That's what the factor function will do for R. It will make a 6-dimensional vector, so it will add 6 extra columns that they're going to be binary. So Monday, so it will be something like that. It will make 6 extra columns. 1, 2, 3, 4. So Monday will be 1, 0, 0, 0, 0, 0. Tuesday will be 0, 1, 0, 0, 0, 0. And, you know, the days are 7, so the last day will be represented, it will be all zeros. That's why whenever you have n categories, you need n minus 1 columns or features to describe it. Oops. be 0, 0, 0, 0. That would be Sunday. Okay, so how is it going?
I have a big LM installed on my R, and
you should try with smaller. If it installs on your laptop or computer, try it with smaller chunks. So do a. You can always do a. Let's open a new whiteboard. So if you're running on Ubuntu, you can do head. Okay, hi Mahesh, you joined. So if you haven't really followed us from the beginning, you can go to this URL that I have posted on the chat.
Okay.
Did you find it? And we started doing the assignments one by one. Oh, okay, we got pictures of you. Well, if you don't have enough bandwidth, you can shut it off. But that's fine. We'd like to see you. Makes more personal. Do you have any problems with your computer audio? I see you're using the phone.
I'm using the phone. Just I thought that'll be the easy one. And so I'll try to.
Whatever works for you.
Yes.
Whatever works for you. So if you're running on Linux and you want to select, let's say, the first 100,000 columns to run the regression, you can do this. 2006.cs, and then you will have to output this to okay, or you can also use the sample function at R. Any progress? You've done this before. You've run the big LM before. Okay. So yeah.
I need to re-download my apparently. I was clearing out some software. I guess I deleted my Ubuntu.
Okay. Okay, just get a wired connection. Mm-hmm. So can you connect him? Okay. So have you installed the Ubuntu Mahesh on your or whatever R on your computer?
No, I did not install anything, but it happened to find out the link today. I just joined.
Okay. So you can start. So here's the thing: you can start working on. I mean, my advice will be to install Virtualbox on your machine, and then we've posted. There is a link. If you go to the wiki, I can send it to you.
Yeah.
So course reading material, installing R, download. So we have a virtual machine that has everything installed, so you don't spend too much time. I just posted the link because it can take too long to and might be a little bit tedious to install things on your system. Every system is different. So start working on that. How is it going with you? So you started.
Yeah, I've loaded Big LM into my R library, and I'm just loading up the data again. It's saying that my directory doesn't understand 2007 CSV, so I'm just making sure that I have that file.
Okay. So now I can go on and start describing things, and then because it might take time for you to download and install things. And again, Mahesh, might be easy for you if to start downloading the image. If you go back to the wiki, you can also follow the instructions to install R on your system and download the data sets we're using. that would be faster because the virtual machine can take some time. So start working on that, and you know, meanwhile we would. I'm going to go through the next assignment. So basically, the other assignment uses runs big linear regression, but it runs that through R Hadoop. Actually, to be honest, it runs that through HDFS. So there is a biglm.integration.r file that you can download. Oops, what happened? We lost contact? Oh, okay. Maybe it's... I'm hearing a sound here. I don't know what it is. So anyway, if you go to assignment number 2, basically what happens is that I think I know what it is. I need power. The problem is we don't have. Can I just use your USB to power up my? Okay. So basically, the regression you're running right now is not truly parallel. The advantage it has is that the one with R Hadoop, it uses HDFS streaming. So it does all this chunking for you. So, you have your data on an HDFS cluster. Let's say this is, 1 terabyte. So here is R running locally on your computer. R. And basically it streams line by line, one line at a time, or actually one chunk, to the big element that you just saw. So basically it's an interface that makes it look like an R data frame, but it keeps streaming lines. So basically, technically, this can scale at least infinitely, in the sense that you will never run out of memory. The truth, though, is that it doesn't run linear regression in parallel. We'll see other examples later on how to make that run, in a true parallel way. So, if any of you, I don't know, Georgi or Jacob, have installed R Hadoop, you can go ahead and try this. If not, then we'll wait when you have it. So let's go to the next part, which is logistic regression. And I want to explain this a little bit so you can understand what logistic regression is. So far, we have logistic regression. So let's review the linear regression as we did it before. Yes. So in linear regression, we had a continuous value, which was A1 times X1 plus A2 X2 plus A3 X3, and so on. So we had a continuous variable here. This can basically be from minus infinity to plus infinity. Okay, it's a real value. It is assumed to be Gaussian, the distribution, and the factors were also Gaussian. Now, if Y now is a as we call it, it's from 0 to 1, 0 or 1. So it's a binomial. I'm putting here a question mark. It's not that easy writing with a tablet, but so if this is binomial, does it really make sense to still have a linear model like that? So what do I mean with the term binomial? Binomial means that it can either be 0 or 1. Technically, you can do it. You can take your data, and since we're talking about the airline data set, which is basically, so far we're trying to predict the delay. So we have a flight, and the factors can be company, airline, day of the month, day of the week, weather, destination, and origin. And you're trying to predict a numerical value. We might want it to predict just whether this flight will be delayed or not. So we would say if a flight has more than 30 minute delay of our arrival, we consider this as a delayed flight, or if it's less than 30 minutes, we consider this as a non-delayed flight. And you can think in life several examples like that, where you have how can I say this? Different classes. Is it black or white? Is this malicious website or not? Will this customer buy the product or not? You need a method. You need a classifier that will give you a result. Now, technically, you can use the linear model. The problem is that the linear model can give you something outside of the boundary 0 and 1. And you can say, okay, if it's too big, I'll say it's class A. If it's too low, I'll say it's class B. Now, in reality, here comes the logistic regression that models the situation more accurately. And basically what it does is that it will... How's your status, Diana? Still downloading, okay. I remember last time you were able to almost run Hadoop on your machine. Even for Hadoop? No, remember Hadoop you installed, you were close. So, So basically now the logistic regression uses this activation function, as they call it, transformation. And as you can see, the exponential underneath can go from 0 to infinity. So if the exponential is 0, y is 1. If exponential goes to infinity, y goes to 0. So basically, by training a model like that, we can guarantee that the values are always going to be between the bounds. Okay, so that's what linear regression does. You give, again, a design matrix with, weather data, aeroplane data, destination data, and a binary label, which is it delayed or not, and it will build a model that, given the factors, it will tell you whether it's going to be delayed or not. So basically, logistic regression is a classifier. So I don't know if any of you tried running a logistic regression on the example. It's a second example. Maybe Jacob or Georgi. Mahesh, I believe you're still downloading things. How about you, Noir?
I'm trying to get my 2007 CSV file to load into my data.
Just make it smaller. Just do sample or chop it.
Well,
do a cut.
It's just that it's, what is it saying? Not open the file. No such file. And you know what? I probably just have to reset where it's reading from file to directory.
Yeah, you could either do I think it's called set CD. I believe it's set CD in, or you can start R on. R has a problem. If you have directories with spaces, it cannot read them. So if you have R on Windows, you should avoid installing it on my programs because R gets confused.
What was the command to set the default directory which it reads?
I think it's called set CD.
And then in their parentheses,
you put the path, yes.
In quotes?
In quotes, yes. Sansan, we got a class. You keep missing. You are such a bad student. It's okay. Cool. We'll withhold it from your salary. We'll hold this from your salary. So I just finished the Hadoop thing. Not year. So Jacob said, okay, so you were able, are you running, Jacob, the VM? We got a winner here. What do you mean by not year here? Let's see. Okay, great. So what do you mean by not year? So Jacob is the first one to run the Hadoop thing. And tell us, what platform are you running on? Are you running on a Mac? Because some people had problems. What operating system? So any luck? Okay. And you're running Windows as a host? Or you're running Ubuntu on Ubuntu? It should work. Okay, so we're right. Jacob ran it and says binomial is giving you an error. And there is a reason why binomial is giving you an error, because don't forget what I just said is that intentionally I put that on the website. The array delay is a continuous variable, and you have to convert this to a binomial variable, to a 0 and 1. So you will create a new. Okay, so let's see how we do that in R. So you have, let's say we are in R right now. You will make R delay 1 equals R delay greater than 60. So basically, this creates R delay now will be a Boolean variable, which will be true if the R delay is greater than 60 minutes, or you can set the threshold to 30 minutes, whatever you want. And if it's less than that, it will assign that to 0. So that's the way you do it. So you have to do that and rerun it, and it should be fine. Takes about what? Okay, it works. Great. Jacob, do you also want to make an introduction? What is the Fisher scoring? Before we answer that, can you make an introduction of yourself? I don't think we... Where do you work? You haven't really come on site, so we have Noir over here, who is the next Steve Jobs. He's an entrepreneur. He's making his new venture. We have... you don't have a microphone in your office. We'll just write it, and I'll or you can send the messages in the chat to everyone, not just me. And Diana works for Cisco. Never really sleeps. Oh, you're teaching at Troy University. Troy University, is this in New York, the Troy University? No, Alabama. Okay, so you're a neighbor. Maybe you can drop by. We're in Atlanta at some point. So the Fisher scoring, to be honest, I don't have an R command prompt right now because unfortunately my machine hasn't really started yet. And let me look it up. You know, this Fisher is a guru in statistics. There's a Fisher discriminant analysis. The Fisher scoring, okay. GLM Fisher scoring. I'm just using at the R documentation to give you an answer. Okay, great. Don't have a PDF. Okay. Great. Now, how do we see? Okay. So Fisher scoring something looks like multivariate critical, something related to the variance. Anyway, what I found is not that clear as an explanation.
R is very slow to load data.
Yes. So I'm looking at Wikipedia, Fisher scoring. Okay. So for those of you who are the Fisher scoring algorithm, so for those of you that are familiar with optimization, okay, so before that, Mahesh said he has a Mac. Try to see if you can import the Ubuntu. Some people had problems with Ubuntu, with the Ubuntu VM and the Mac. So okay. So anyway, the way that that's fine. You can. It's going to take time. So basically, solving regression. Okay, let's take the linear regression. Okay, you have to find. It's an optimization problem. It's minimizing over all possible x's. You have to minimize that. Now, with generalized linear models, you use the Newton. So it's again an optimization problem. So you have to minimize over x and f of x is this function that we discussed before. Okay, so when you solve this optimization problem, you use the Newton-Raphson method, and as I found, and you can look at Wikipedia. It says that this is another name for that is the Fisher scoring algorithm. So it's a variation of the Newton method, not Newton-Raphson. Sorry, Newton-Raphson is different. So you can take a look here, Wikipedia, but it's really not very different than, you know, it is. And you can look at, okay, if you want more information, you can look at Hasty and TBC Rani's book, the one that I have posted on the website. So this for those of you who are new, I highly recommend to go through the wiki and look at the pages. There's also reading material. So basically, in order to solve this optimization problem that for logistic regression, it turns out that it's you have to solve a sequence of least square problems. So it's a more intensive method, you know, logistic regression, just because you have to solve many least square problems. So it's more tedious, but well, if that's what you have to do, that's what you do. For when the number of factors grows exponentially, then you need to, not exponentially, when it's too high, then there are other types of methods. So far we're looking at problems that have many observations, points, many x's, but the size of x is fairly small. It's not more than 1,000. Maybe after 10,000, things start to become. Actually, I don't think I can go more than 1,000, unless you're using the Revo scale one, which is much faster. So yes, that's the case. For we can only scale in the number of observations, but not in the dimensions, like the number of columns. Then again, if that grows, there are other stochastic gradient descent online methods that can deal with this. Let's open the whiteboard. Now, how is the class doing here?
I've loaded the data.
Any luck with the Ubuntu? Okay. So, since we have somebody who was able to... so are you able, Jacob, to run the big logistic regression? So, okay, Georgi is asking, obviously he joined fairly recently, he wasn't ready. So right now, yes, you install the VM. It's always nice to use the VM because we have installed all the packages we're using so far. Of course, we're going to install more, but some people on their platforms used to have some dependency problems. R is not terribly friendly in installing packages always. So it's always good to use the VM. Now, this particular VM also has installed Hadoop and R Hadoop. And right now, it runs Hadoop locally, so don't expect to see any big performance gains. Actually, even if we were running down a cluster, you wouldn't really see big performance gains just because it still uses one CPU and it's DFS streaming. Further, as we move on, hopefully Brad Anderson will give us access, or we'll be able to set up a Hadoop cluster, and we'll make it possible so that your VM, local VM, collects to a much bigger Hadoop cluster on the cloud, and you'll be able to run your tasks from there. So we're still experimenting with small data. And I don't know if this is covering you.
So so I tried attach my data, and my Windows is no longer responding.
Okay. Did you re-download Ubuntu?
I was installing it, setting up the virtual machine.
Oh, okay.
While I did that, we'll see.
So, Georgi, also give us an introduction about you, so that we know it's good to network too. By the way, until you write to us, again, our sponsor here is Logistic and Predictix, that they're giving us equipment, space. So anybody, if you want to introduce yourself, Mahesh or Georgi, yes, please feel free to introduce yourselves. So yeah, I was saying Logistic and Predictix are offering the space and several other things.
Yeah,
okay.
So this is Mahesh.
Okay, hi Mahesh.
Hi. First of all, thank you for arranging this kind of platform to learn the new technology. That's
You're
very
welcome.
much. I really appreciate that. And it happened to search. I found it in Google, not Google, LinkedIn. That's how I joined today. But sorry for that. But other than that,
that's okay.
to introduce myself, I'm from California. I'm in the Bay Area. So I joined on this. I'm working right now as a consultant at Google.
Oh, okay, great. So yeah, Mahesh is joining us from Silicon Valley, and he's working from Google. Georgi here said that he's interested in big data. He's working for telecom now, and CRM as well. Okay, so you're working for Google as a consultant. Yeah, you working on a specific product? Are you allowed to talk? I know Google is kind of secretive.
A lot of secrecy, but a lot of privacy related. But my product is right now. What we're talking about is, we're not related to the big data. Big data is an engineering platform I use in the front end reporting area. That's called BI. So in-house BI reporting application we have. So internally in the backside, we connect to big data. So MapReduce, column IO, record IO, and what we use is a Dremel. Dremel is multi-faster than the regular SQL to query the data from the record IO and the column IO.
I see. Okay.
So the one I want to learn is, I've been thinking about this. I've been in the BI industry for a long time. I've been thinking about how this data file structure can read or can put together in the reporting platform, how fast we can do, what is this MapReduce and R is going to do there. So we don't have, from my team point of view, we don't have exposure to that area. That's an engineering department.
Okay, great. So, yes, if you want to go back, so basically you've missed the first class, and you can go back in the wiki. We have for every class what we're doing. It's documented. It's probably 90% over there. There's also, I think we also record the WebEx sessions, and I should post the WebEx from the previous course, so you can go through that. But I believe it's fairly easy to go through the examples from the past session. Now we used to have 2 days, one Thursday and one Friday. Now we're gonna merge everything to one day, Thursday. People come and go, and I think people, if they miss a class and they get disappointed, they think they can't follow up. But most of the classes are, self-contained. So let's see how the people here on site are doing.
My computer crashed.
Your computer crashed, so you have to restart it. It can happen even happens at Google. What about you, Diana? Let me also introduce the people here, like you can get a view of the class. Usually we have more people today. We're not really, I don't know what happened. Okay, here's the class. So what stage are you right now? VM working? What? Oh.
I'm quickly just setting everything back up. I was just gotten there, and then everything stopped. Trying to quickly set it up.
Okay, so if Jacob has finished with Hadoop, whatever our Hadoop regression. It's, by the way, I had a discussion yesterday with Revolution Analytics, who supports our Hadoop, and they're also putting more effort. The problem was the project was kind of like stalled for some time, but they're going to put more effort to improve it. They're really excited that people are using it, and they want feedback, which we plan to submit. So again, we are going to have, so we run logistic regression first, then we talk about it's number 4, the big logistic regression. These are pretty straightforward. If you download the VM, you should be able to run them. Now, there's the other thing called the regression tree. So, you know, as you're waiting, most of you, for things to download and things to run because they take time, that's the, okay. So, yeah, my has just left temporarily. This is the beauty of big data. Big data take a lot of time, unless you have the equipment. So let's talk about regression trees. Now, let me make a plot. So imagine now that you have your data, like the delay of arrival is what you're trying to predict. You have the origin, the destination, day of the month, the distance. Okay? And somebody comes and tells you, well, if you were allowed to use only one factor to make predictions, which one would you use? Okay. So I don't know if you remember from the previous course when we were running stepwise regression, where we said, you know, in stepwise regression, we start with the factor that best predicts the data. So we try them all and we pick the one that best does that, and then we search for whatever is left, and from all these, so we pick. If you remember, like the factor that was very informational was distance. I don't remember correctly. I think it was distance. Then we tried. Okay, now we have distance. If I add another factor, which one should I add to improve my forecasting, my prediction? And we kept adding. Now in regression trees, we'll say you have a factor that you have to pick, and you can only ask a question about this factor. So it will say, if I pick day of the, oops, we lost somebody, yes. If we pick day of the week or distance, and we want to make a prediction, you're only allowed to ask the question if the distance is less than a certain value or greater than a value. Or you can ask the question if what is the day of the week. So if the day of the week is Monday, Tuesday, and Wednesday, then I partition my data. So basically, let me give you an example. So think about all these data points. They are in 2 dimensions. This is distance, and this is, let's say, something else, not really day of the week. Well, we can, for simplicity, we can say day of the week, or maybe, let's say, weather temperature. Now, and imagine that all these points over here have values that they are close. Now, the question would be, if you were asking what is the weather temperature, there's no way you can discriminate them. So if you're asking a question, was the weather temperature less than, 70 or less than 80, like any line that you draw over here won't be able to discriminate these two clusters, or whether you put it here. So there's no really a question that makes your decision accurate. Now, the contrary, if you ask the distance, you see that there is a question which says, is the distance less than 1,000 miles? Like if you ask this question, if the question is yes, you get this cluster. If it's no, you get the other cluster. So what I'm trying to say here is that the decision tree is a method. So forget about the word regression. Let's make a decision. Let's make the decisions binary to understand it better. It's always better to start with a decision tree, not with a tree. So the decision tree is a classifier, okay? And the way it works is you can only ask questions. And the questions are typically Boolean, which is it less or equal? Is it Monday or Tuesday? Okay? So decision tree will try to find factors that asking question is giving you something useful. So let's say, for example, you are a doctor and you want to make a test or a decision tree to find out if somebody has cancer. And you can start asking questions like, the color of your eyes, is it blue or green or black? You can ask, do you have high blood pressure? Or you can ask, do you smoke? Now, obviously the question, are your eyes green or not? It's not really very informative if it is the first question you're asking. Because if we run a survey and we see that people with blue eyes have 50% probability of having cancer, and people with not blue eyes, other colors, also have 50%. So asking this question is not really giving you an information. On the contrary, if we were asking, do you smoke or not? The distribution will be skewed. So if you say yes, the probability of having cancer would be 80% or 60%, while not having cancer, you're not smoking, would be 40%. So that's an informative question, which means that asking this question separates your population in a better way. Now, it turns out if you smoke, then if your father died from a heart disease, and if your eyes are blue, like asking that question at that level, it might actually give you an information. So it means that, yes, people with blue eyes, I'm just making it up, it doesn't have any scientific value. Given some other factors, it can be informative, okay? So that's what the decision tree does. So, you start with your data here, and let's say this is class A. This is class B. Sorry. So, as you can tell here, the decision tree, if we try to split that way, like this would be a very bad split. Why? Because the probability of discriminating data on the left side is not really that greater than on the right side. So you see that both kids, like this is the parent node, and this is like the left and the right kid. In the left kid, we have classes, like 50% of the classes of the points are class A, and 50% are class B. And here, again, the same. So it doesn't really have any good discriminative power. Now, if I choose to split this way, here I've got much cleaner clusters. I put it that on purpose. Like you see that this, whatever left kid or upper kid, is 90% class A. This is class A. And the other kid is probably 99% class B. So that's a very good, split. Now, when I go to this kid, let's make it a little bit. It makes sense to make a split over here because immediately I'm able to separate my classes. And again, over here, I would make a split over there. So now I have a decision tree. Have you ever done decision trees in ISWA? Okay. So in a decision tree now, if somebody gives you this new point, query point, what will you do? You will go to the parent and you will ask this question. And this is your first split, sorry. Is it left or right of my decision line? Okay, it's left. So it must be in this area. Then you ask, is it left or right here? It's right. So under this recursive system, you were able to find out the leaf node where your query point belongs. Now, in this query, in this node, I see that 75% of the points are in class B, and 25 just one is in class A. So I'm assuming that the class of this query point is B with 75% confidence. Okay. Now, if I was okay. So, if my query point was here, again, through the recursion, I will say, okay, I go down and left. I will say, okay, it belongs in this node, and this node is 100% class B, so I'm very confident about that. Now, the same here. These are very clean clusters. If it was here, it would be 95%. So basically, the idea is that the decision tree starts to making splits and kind of like identifying rectangle areas. That if you really want to find out what it does, is that it does rectangular partitions and it tries to find rectangular areas that are pretty clean, pretty clear. Now, somebody would say, why don't we keep splitting, for example? Like you can keep splitting over here and then split over here. So wherever you end up, you can make a better prediction. So there is something we discussed in the previous class. It's called generalization error, which means that if you start really splitting, then you will start making very small rectangles. And basically what you are saying, like if you make this split over here, you somehow generalize and you say this area belongs to this class and not this class. So this is called overfitting. So the way that the decision tree works is that it will do partitioning until it makes, oh, we got a new student. Ah, that's you, the D? Okay. Hi, D. So as we are making the splits, so the algorithm, the CART algorithm, what it will do is that it will split until, probably we'll make another split here. Sorry. It's not very accurate. So it will have nodes that they are leaves that they are 100% clean. But that's a problem because that doesn't generalize well. So basically, after it makes perfectly clean leaves, then it will start do pruning. So it will prefer, for example, to have nodes that they are not clean, but they generalize well, rather than nodes that they're pretty clean. It's just the same thing we discussed with regression last time about Reed's regression, if you remember, where we had a lambda parameter to cross-validate, because it turns out that your goal over here is not to make a model that models your training data 100%. You want to make a model that also generalizes in data you haven't seen. So basically, as you keep splitting, you increase the complexity of your model. Your model takes more memory. Complexity means in order to describe it, you need more memory. So it becomes very accurate at training data, but it's not accurate on data that it hasn't seen before. And in another way to remember, we discussed it last time to see that is that, instead of running linear regression, we can model our data with a very big if-then-else statement. If your data is 0.553 and the delay is that and that, then do this. So we could make a model that it would describe our training data 100%, no zero training error. But the truth is that we have horrible generalization. So that's called the Occam's razor. And that's like the cornerstone thing in machine learning. Find the optimality where your model complexity is, is as low as possible, and the generalization error is also low. So now the regression tree does exactly the same thing as the decision tree, with the only difference that instead of, once you do the partition, instead of, how can I say this? Instead of doing a voting scheme and say, okay, I have 75% A or 25% B, it will just take the values of this point. So this point might have, a 0.3 value. This might have a 0.35, and 0.33, and this might have a 0.1. So in order to find the query, the value of the query point, it will just do an average on all these values. So basically, you want to do partitioning. Well, think about that. In decision tree, you want to do partitioning where all these points have the same value, class 1, so if it's 0 and 1. In regression, you want to make sure that all the points in this partition have values that they are very close. So in regression, it's pretty, in classification, it's very straight, 0 or 1. In regression, this could be 1.1, 1.2, 1.01, so that when you take the average has very low variance. Okay, so how did you manage to connect Diana on WebEx? Also, you did it through the Ubuntu, the virtual Ubuntu? So right now you're running the Ubuntu from the Virtualbox? Okay, so which one is being able to run WebEx now? The Windows one. Great. So Ubuntu wasn't able to run it before. Okay. So are you able to run R Hadoop? Was anybody able to run the logistic regression with R Hadoop? Well, try to run. Yes, it's lesson 2. Actually, you've also taken lesson 2. You're taking lesson 2 twice.
So I've loaded it up, and I'm doing day per week. I'm running big regression, right?
Yeah.
Yeah, I'm doing that right now.
On your Ubuntu?
On Windows.
Okay, so the goal is also to you were able to install the Virtualbox with the Ubuntu.
Correct. Well, the thing is, in order to sustain the RAM, I have 4 gigs.
Oh, okay.
About 90% of my RAM is being taken up right now, just running.
Oh, okay. So my advice is at some point switch off your Windows and switch over to. So let's see if we have any news from the remote students. Okay, with Hadoop, yes, I can run. Jacob, you are our hero today. Well, things would have been easier if everybody, I know it takes time to, download it and install it. And I'm in the same situation like you. I'm doing that on my spare time. And believe me, it takes a lot of time to run the examples, validate them, make sure that the Virtualbox is working. So anyway, you can move on now that we discussed well, let's finish the theory first, and then you can go ahead and run the regression tree and the decision tree. We'll probably end the class earlier today since we're just 4 people. So there's two ways of training a regression or a decision tree. The first one is, and you don't really have to do that, R or whatever package you use is doing this for you, but it's always good to know. So the first one is that you really make very, very careful partitions, like deciding which partition to take is really tedious because you have to try all possible, in decision tree you have to find all possible factors, and you might have 1,000 factors. So at every step you have to find which one does the best partition for you, and then find out which question to ask. That also takes time. And then for regression, you also have, once you find the factor that you do a split, you also have to find out where to split, like less than 10, 20. So it takes time. And then once you do all the partitions, you have to do the pruning, which pruning means like I try pruning this and I test pruning this. So it can also take time. So you spend a lot of time making careful decisions about how to train. Now, you might have heard of this term called, let's add another whiteboard. It's called random forest. Have you ever heard this term? Never heard random forest, Diana, before? It's natural. I hadn't too. No, it's really simple. So the idea is that instead of taking all this time to do this careful partition, you make inefficient partitions. It means like you don't try everything. You choose your partition randomly. Okay. So, but you don't train one tree. You train a forest of trees. So you just run. Again, you do your partition randomly, so you don't have to train. Sets exhaustively, and you don't prune. Actually, you just stop at a random level where you define, and you build 1,000 decision trees that they are inefficient, like weak. They're not perfect. To be honest, training a perfect decision tree is NP hard. It's a combinatorial problem. But even with other before, so you train a bunch of them, and eventually, instead, when you have to evaluate a new query point, you send it to 1,000 decision trees, and you get the answer. You do a voting scheme. So as you understand, R Hadoop is ideal for that. And I don't think this is implemented in R Hadoop, but if you know the S apply and L apply and all these commands, which that was kind of like, I don't really know if we have the time to do it. I'll try. But the idea is that with R Hadoop, you can train 1 million, if you want, random forests, and then evaluate them very quickly. The reason I said we have 2 or maybe 3 different types of people over here. Some people that they're more interested, they're not really interested in big data. They're interested more in, running small data and being able to do exploratory data analysis. So for example, if you remember in the previous class, we were talking about, okay, I have a question about PCA. I'll come later about that. I will explain. So as I said, some people, they want to run regression and being able to answer question in analytics. So which thing is, you remember from the previous class, for those of you who were here, we were trying to find, factors that affect delays, or, do exploratory work, and being able to solve problems. And then we have other people that they say, okay, I know what I have to run. I have to run a regression or a classification problem. It's just that it's not running on R efficiently. How can I make that scale? So for people like that, it would be ideal to spend some time, coding simple solutions. But you're spending more time on the coding part and making that scale rather than making a more complicated model. And of course, we have other people that are interested in the R language, like the students we had last time, that they moved to the Friday course now. And they're more interested in, being able to use R for coding their own algorithms. We'll do that on the next semester. That's a great book. You see people passing by. It's a very active environment here at the Logistic. So we have a question like, is it still faster than PCA? So PCA, we haven't really tested. We're going to talk about it in the next course. Is a little bit different. PCA, that's a different thing. It's not. It's more like a clustering or a dimensionality reduction method. It's not a classification algorithm. So PCA will sort of make combinations of your factors that they have information. That's what PCA will do. PCA will take linear combination of the factors, a little bit from a day of the week, a little bit of a distance, and it will make a new factor that kind of like gives you information about your data. It's not a great method if you want interpretability or finding factors that are significant or insignificant. It's great if you're trying to do compression or if you're trying to do clustering, as we're going to see in the next course, in the next week. So keep that question. I hope I answered that, Jacob. There are just two different methods. Random forest and PCA are trying to solve different problems. Okay, in a sense, you could use PCA to transform your data and then run a random forest. That's legitimate. We saw that we did that for regression, for example. If your regression is unstable, you remember when we found out that if you put extra factors that they carry the same information, regression becomes unstable. If you use PCA as a pre-processing step for that, then it's great because it will create less factors that they have all the information. So if you have, for example, a random, wanted to build a decision tree with a million variables, and you were suspecting that, most of them are redundant, so it would make your random forest completely inefficient because you would have to make many, or your decision tree, very inefficient because you had to search more factors. Then yes, I would do PCA first, come up with 10, 20, 30 components, and then build a random forest. So let's see if we have anything left. So I don't know if anybody was able to run through the examples I have over there. I think for the random forest, I haven't really put anything. It's just because people from the Friday class weren't able to do that. So somewhere here, we're going to end the sessions for today. We are going to repeat decision trees and random forests again, so please do the assignments because I want to bring you in the same level with the Friday students. And the Friday students, we spent a lot of time trying to install our Hadoop, and we didn't spend that much time on random forest, and regression tree is still running. Yes, and as I said, regression tree is going to take a lot of time. It's slower than regression. I believe there must be a parameter to tune it and tune it. That's in the random forest, I believe. We'll talk more about that, because your regression trees will try to do a lot of exhaustive, searches. Now, I want to also mention before we close that regression tree and decision tree are non-parametric methods. So if you remember so far, for linear regression, we made the assumption, or for logistic regression, that your data is following a particular distribution. Like they have to be Gaussian or they have to follow binomial. Now, regression trees and decision trees don't really make any assumption about that. They're pretty generic. They can model almost everything, and that's why the industry likes them. Okay, so with that, I'm closing for today. I'm signing off. Are there any questions? Please feel free to post them on the forum. I'll see you next Thursday. We'll merge the two classes over there. Okay, so let's see how we end the meeting over here. Sorry. End meeting.